The Sun is the nearest star to us. The distance from the Earth to it by space parameters is quite small. From the Sun to the Earth, sunlight is only 8 minutes. Sun is not an ordinary yellow dwarf as previously thought. This is the central body of the solar system near which the planets revolve, with a large number of heavy elements. This is a star formed after several supernova explosions, in which a planetary system was formed. Due to the location close to ideal conditions, life appeared on the third planet, Earth. The sun is 5 billion years old, but let us see why does it shine? What is the structure of the sun and what are its characteristics? Wait awaits what awaits him in the future? How much influence does it have on the earth and its inhabitants? The sun is a star around which all nine planets of the solar system, including ours, revolve. 1 AU astronomical unit equals 150 million kilometers. The same is the average distance from the earth to sun. The solar system includes nine large planets, about 100 satellites, many comets, tons of thousands of asteroids, small planets, meteoroids, and interplanetary gas and dust. The center of all this is our sun. The sun has been shining for millions of years, which is confirmed by modern biological studies obtained from the remains of blue algae. If the temperature of the sun's surface by changed by at least 10%, and on Earth all living things would die. Therefore, it is good that our star evenly radiates the energy necessary for the prosperity of mankind and other beings on earth. In the religions and myths of the people of the world, the sun always occupied an important place. Almost all peoples of antiquity, the sun was the most important deity. Helios, the ancient Greeks, or the sun god of the ancient Egyptians, and the slaves Yarilo. The sun brought warmth, the harvest, everyone worshipped it because without it there would be no life on earth. The size of the sun is impressive. For example, the mass of the sun is 3,30,000 times the mass of earth and its radius is 109 times greater. But the density of our density of our starlight is small, 1.4 times more than the density of water. The movement of the spots on the surface was noticed by Galileo Galilei himself, thus proving that the sun does not stand still but rotates. Convective zone of the sun. The radioactive zone is about 2 of 3 of the inner diameter of the sun, and the radius is about 140,000 kilometers. Moving away from the center, photons lose their energy under the influence of the collision. The of the collision, this phenomenon is called the phenomenon of convection. This is similar to the process that takes place in a boiling kettle. The energy coming from the heating element is much more than the amount that is removed by conduction. Hot water located in the vicinity of the fire rises and colder falls down. This process is called the convention. The point of convection is that the denser gas is distributed ever over the surface, cooled, and goes back to the center. The mixing process in the convective zone of the sun is carried out continuously. Looking through a telescope at the surface of the sun, you can see it granular structure granulation. This feeling is that it consists of granules. This is due to the convection taking place under the photosphere. Photosphere of the sun, a thin layer 400 kilometers. The photosphere of the sun located directly behind the convective zone and is visible from the Earth's real solar surface. For granules on the photosphere photographed by Frenchman Jensen in 1885, the average granule has a size of 1,000 kilometers moves at speed of 1 kilometers per second, and there are about 15 minute dark formations on the photosphere can be observed in the equatorial part and then they move. Strongest magnetic fields are a distinctive feature of such spots, and the dark color is due to lower temperature as compared to the surrounding photosphere. The chromosphere of the sun. The chromosphere of the sun colored sphere, a dense layer, 10,000 kilometers of the solar atmosphere, which is directly behind the photosphere. The chromosphere is quite problematic to observe due to its close location to the photosphere. It is best seen when the moon closes the photosphere, i.e., during solar eclipses. Solar prominences are huge emissions of hydrogen resembling long fibers. Prominences rise to great distances, reaching the diameter of the sun 1.4 million kilometers, moving at a speed of about 300 kilometers per second, and the temperature at the same time reaches 10,000 degrees. Solar corona. The solar corona is the outer and extended layers of the sun's atmosphere, originating above the chromosphere. The length of the solar corona is very long and reaches value of several diameters of the sun. The question of where it ends, scientists have not yet received a definite answer. The composition of the solar corona is a discharge highly ionized plasma. It contains heavy ions, electrons with helium nuclei and protons. The temperature of the corona reaches from 1 to 2 million degrees K relative to the surface of the sun. Continuous flow of matter plasma from the outer shell of the solar atmosphere. It consists of protons, atomic nuclei, and electrons. The speed of the solar wind can vary from 300 km per second to 1500 km per second according to the processes occurring in the sun. The solar wind propagates through the solar system and interacting with the Earth's magnetic field causes various phenomena, one of which is the northern light.